Okay, so hello everyone. This is Alex, and I'm making this video for public finance for development problem set 3. And for this problem set, let's start. For the first part, question 1, we have two big questions, two big problems in question 1, A and B. For the first one, A, it is mainly about the behavioral economics. And I think to answer these questions, you must understand the idea, like the concept of first saliency bias, and second, loss aversion, and maybe risk averse. And third, you'd better understand anchoring. And fourth, maybe reversion to mean. So what is saliency bias? This one is, let me use a red pen. This one is more likely to remember maybe the most prominent thing. So we can see maybe question, not question, number one A, a friend complains that he always chooses the quiz at a supermarket that takes the longest time to reach the counter. So it maybe he just remember those days when he has chosen the longest quiz, and because that's a really bad day, and so he remember clearly. So he thought he always choose that. So this can be a saliency bias. And what about loss aversion? Loss aversion, people tend to be more risk averse in facing loss, comparing to facing earnings or income. So that's a loss aversion. So that's when people get more risk averse when, maybe not when, in loss situations. For example, thinking of you are buying like a stock, and if the stock earns some money, maybe you will sell it and realize the capital gain. But if the stock, if the price is going down, you don't want to realize the capital loss, because you are really loss aversion. You are loss aversion. You don't want to directly realize the loss. You expect the price to come back to the original level or maybe higher again. So that's loss aversion. And anchoring means if I give you something as an anchor, we call it an anchor, and you get some idea, you get some impression of this thing, and then all the following judgments can be made around this anchor. So it's like I think many big companies, they use this strategy to sell their products, like the Coach. If you walk into a Coach store, first they will put the most expensive but the fanciest, the coolest thing in front of you, and then you get an idea, oh, this is the Coach level and this is the price, like for a Coach bag. And then maybe if you keep moving around in the store, and you find something is cheaper and much cheaper than the product that they show you in the first place. So you find maybe the price is really acceptable. So this is anchoring, because the company has anchored a price in your mind. So this is an anchoring bias. And the last one is reversion to mean. So this is like the regression. I think we all have learned regression. So this should be an easy one. And so for all the questions, question 1A is a saliency, and question 1B, flight instructors training new pilots would praise rookies for good landings and scold them for bad landings. They notice that pilots do worse after being praised and better after being scolded. So this is a reversion to mean, and try to explain by yourself, maybe a little bit. And I will skip C and I will skip C, D, E, F. I think we can get the right one by yourself. C to F. I can give you some hints. I think 3 saliency biases are used. And 1 anchoring, 1 reversion to mean, and 1 loss aversion. So that's in total 6. You can maybe try to match which one to which one, and for A to F, A, B, C, D, E, F. Okay, so that's number 1 and number 2. Then let's go to number 3. Consider a decision maker Dick with a utility function over gains and losses defined as follows. So if he's offered a gamble in which he wins $200. When he wins $200. And when he loses, he will lose $100. So negative 100 when he loses. This is 40% and this 60%. So will he take the gamble? So we can do the expected value, right, of the expected value of the outcome. So expected outcome equals to 200 times 0.4 plus negative 100 times 0.6, which equals to negative 10. Am I right? Oh no, since the utility level, right? No, this is not. This will gives you a number of 20, but this is not correct. Since he's making his decision based on utility, I think we have clarified what is the expected utility. And the utility of expected income. Those two things are different. So here we are asked to calculate the expected utility because one will make his or her own decision based on expected utility rather than utility of expected income. So the expected utility from the gamble, expected utility from the gamble is U1 times the probability of 1 times 0.4 plus U2 times the probability of situation 2, 0.6. And U1 equals to U $200, which is 200. And U2 equals to U negative 100. And from the formula we are given, when x is smaller than 0, we have to calculate it as negative 1.5 times x, right? So yeah, I think there should be only one negative sign here, so we can erase this one. So 1.5 times negative 100 is negative 150. So you calculate this, you'll find the expected utility will be negative 10, which is smaller than 0. So he will not take the gamble. That's I. And number 2, suppose he is offered instead 2 independent gambles. So for 2 independent gambles, we have 3 situations here actually. Here for this one we have only 2, U1 and U2, but in this one we have 3. So let's do a table first. The 3 situations should be win 1, lose 1, win 2, and lose 2. And what are the outcome maybe? What are the outcome in monetary terms. The outcome. If he win one, lose one, his income or his outcome will be positive 100. And if he win two, there will be 400. And if he lose both, he will lose $200. And what about the expected utility? Not the expected, sorry. What about the utility level for those three situations? Positive 100 utility level will be 100. Positive 400 utility level will be 400. Negative 200 utility level will be 300. You can use the utility function to do this, to get this out, to get these results, utility. So this is U1, this is U2, this is U3, and the expected utility will definitely be U1 times the probability of 1, plus U2 times the probability of 2, plus U3 times the probability of 3. Yeah, I will leave you some blank here. You can try to calculate the probability by yourself. Okay, so probability of 1, I will give you an example. For the probability of situation, maybe situation 2, if he win both, means in the first gamble, he has to win. If he win, there's a 0.4%, 40%, 0.4 chance. And if he want to win the second one, there should be another 0.4. So you times 0.4 by 0.4, and you get 0.16. This will be the probability of situation 2. And we can do a we can multiply those two numbers here because those two gambles are independent. If they are not independent, then we cannot directly multiply their probability here. We have to use what's that called? Conditional probability? No, maybe a Bayes function, Bayes formula, something like that, to do this. And if you do everything right, the final number, the final expected utility will be 4. You can use this to check. But remember to show me your calculation here. Show the calculation. Otherwise, I will mark you off. Calculation for the probability. Okay. So this is number 2. And from this, we can see if he is making a decision on 2 gambles, maybe he will enter into the gamble. He will play the game because he has a positive utility. And what's the reason for Dick joining 2 gambles but quit in 1 gamble? What's the reason for that? That's the answer to question 3. That's something called the myopic loss aversion. Myopic loss aversion. So this is maybe can be replaced by the short-sighted. If someone is short-sighted, so he ignoring maybe the events in the future, means he will be more risk averse. This actually means if one ignores the future events and only looks into the short term, then he or she will be more risk averse. Since you are ignoring, maybe not only ignoring, you are how to say, subjectively choosing to ignoring. if you are ignoring the chances to win back your money in the future, then even the game is designed okay, but you will not to choose to play the game. So that's something about the myopic loss aversion here. So we can see we can use this to explain the equity premium puzzle. So equity premium puzzle. equity is a choice, is a way of investment, right? Of personal investment. And another way of investment is you can investment in fixed income investments like bonds, treasury bonds, company bonds. And here means you are investing in stocks. We find that the returns for stock is usually higher than return in bond. Why is that? Because that's because of myopic loss aversion. For fixed income investment, you are always looking a long view. You are always looking your investment in a long term. But for the equity, maybe sometimes people get myopic and they get short-sighted. So they are only focusing on the money, maybe in this month or in this year. Yeah, so they will find that their investment, if they find their investment a loss, they will be quite risk averse and they will sell the stock. And that's why the stock market offers a higher return to maybe stimulate people to join, to participate in the market, to trade in the market. So that's part of the explanation of the equity premium puzzle. But actually, this is more complicated. This is in reality, this is more complicated. Here, this question just gives you an example to think about how to explain something with the concept of myopic loss aversion. So question number 4. In a famous article by Paul, this guy, he offered a bet to his colleague, where his colleague could flip a coin, either win 200 or lose 100. I will keep reading the question. So A, how can loss aversion account for the above anomaly? Yeah, so this is about the loss aversion. This is myopic loss aversion, or maybe myopic risk averse, but here is more about loss aversion. We don't like loss, we like gains. So question A, how can loss aversion account for the above anomaly? The loss aversion, yeah, means someone will value the loss very highly. If he lost, maybe A, we call it A. If A loses $100 relative to a gain of $200, maybe he thought those two are the same. Those two are the same for maybe on utility level. That's why he will not play the game of either losing 100 or gaining 200. But if you gave him a $100, for sure he will definitely accept that. But that's because the money is gained from certainty. Here is about the loss aversion. A is more loss of. This is also something about myopic loss aversion. A will not. This one, A will not play the game because he think there's a chance that he will lose $100. He really don't like the result of losing $100. And however, when aggregating all the gambles together, when we can play multiple times, then the results shows that the results shows that people can actually maybe earn money from the game, and so people will enter into the game if they are thinking in a long term. But in the short term, they will not play the game. It's actually it's kind of the same as question 3. And B, how can this insight help investing behavior? So I think the key word should be we are trying to have a lifetime horizon, or maybe a longer horizon in investing. Try to make investment decisions based on a longer term horizon instead of instead of trying to earn quick money and trying to avoid like quick loss in the current period. If you are having a long-term horizon, and you will make maybe better decisions, and you will find there's always some returns, and you can you can always gain some returns from the investment, from the financial tools. So that's for part A. Part A is more conceptual, and part B and question 2 will be more about calculation and maybe even graphing. Part B. This is called anti-poverty. Oh, I'm sorry. So structure is part A and part B. Part B there's question 1 and question 2. I think I misunderstand the structure, but it's okay. So part B, question 1. It's about the leisure and consumption. So typical or traditional leisure and consumption, the budget constraint looks like this. This is a leisure. We put leisure on the x-axis, and we put consumption on this side. And don't ask me why, because this is everyone is doing this, putting leisure on the x-axis and putting consumption on the other side. One answer to this may be the consumption is measured. I mean, the unit of consumption is $1. So it's kind of like the AOG, all other goods. And we like to put all other goods on the y-axis. Leisure, the unit is hour. So the more leisure you consume, well, one logic is the more leisure you consume, you are actually working less. The more leisure you consume, the less work or less labor you provide to the society. So sometimes sometimes the government want to ensure your income, but they also want you to offer a certain amount of labor to the society. So this can be some policy related issues. So a budget constraint can look like this. And the slope, what's a slope? The slope is actually the wage. Because for one additional leisure, it's rise over run, right? It's delta y over delta x, rise over run. And this means for one additional hour of leisure, one additional hour of leisure, how much, I mean, how many compensation, how much consumption will you give up? How much consumption is also maybe how much income will you give up? So that's maybe the income you give up for an additional hour of leisure is your income. So this is the logic. Yeah, right. So the additional hour of leisure is cost you an hour of income to enjoy the leisure. So let's go to A. And try to draw, yeah, this question asks you to draw two utility curves and 2 budget constraints on each graph. So the first one, the government is transferring actually $5,000 per year, regardless of someone's earnings. So that's like a direct income transfer. With a direct income transfer, we have a direct income effect on your budget constraint. Suppose this is your budget constraint. Actually, we have the numbers, right? The leisure, the maximum amount of leisure will be 200, right? 200, 2,000 per year. Yeah, 2,000 units of leisure. And the other side will be, if you don't consume leisure, you earn all the money and you earn 20,000, 2,000, 20,000, because the slope will be negative 10. 10 will be your wage. Yeah, your wage of $10 per hour. Okay, and after a direct transfer, your income will there will be a parallel move of the budget constraint. So this will be a new one. Yeah, I think we learned this from the micro one part. The income effect will shift the budget constraint outwards, and the distance will be 5,000, will be the amount of the income, the actual income the government has provided to you, actually the money transfer. So this number will be 25,000, and this number will be 2,500, and the slope will still be negative 10. So that's question A. Question B, number B, the government guarantees 5,000 per year in income and reduces the benefit by $1 for each dollar of labor income. So you earn $1, you get $1 less from the transfer, which means you earn $5,000 or more, you will not quit, maybe you will be excluded. You will be excluded from the program. And what does this mean? You earn $5,000 or more. Means you work how many hours? $5,000, 10. You work $500. You work 500 hours or more, which also means you enjoy less than, right? Yeah. You enjoy less than 1,500 hours of leisure. So if you enjoy less than 1,500 hours of leisure, or you earn 5,000 or more, that's the same, you will be excluded from the program. So let's see which part of the people will be excluded. This is the original one, leisure consumption, and 20,000, 2,000. So there's a number of 1,500. If you enjoy less than 5,000, if you enjoy less than 1,500 hours, means on the left side, right, from this point, this part of the people will be excluded. So their income, their consumption will not change. So the red line, the new one, will go like this. And now let's think about the people who earn less than $5,000. If you earn less than $5,000, the government will always make your income or make your consumption to $5,000. So this will be a horizontal line until the end. And this part may be not real, since the person who choose not to work at all and enjoy 2,000 hours of leisure will still get a $5,000 transfer from the government, and his consumption level is still $5,000. So that's a new constraint for the budget constraint, number 2. No, new budget constraint, the right line. Okay, and you can label this maybe this is $5,000. So actually this policy will only focus on the poor people. And question number C, the government guarantees 5,000 per year and reduce that benefit by $2.5 for each $10. So this is a little bit complex. So still $5,000 per year, but reduce $2.5 per $10. Per $10. What does this mean? Reduce $2.5 per $10, which means all the $5,000 will be reduced. 5,000 over 2.5 will be reduced when you earn. This will be $20,000. So all the amount will be reduced, or will be deducted, will be taken if you earn more than $2,000. 20,000, sorry. If you earn more than $20,000, more than this amount, you receive nothing. Nothing. Otherwise, you receive $7.5 for, oh, no, not like this. Otherwise, each $10 you earn, the transfer is reduced by $2.5. Mm-hmm. So yeah, let me see. So this means when you earn zero income, you will get $5,000. You will get all the $5,000 as a money transfer. But when you, yeah, so it's like a directly money transfer, but then the government lower your wage by $2.5 per $10. So each this is your hourly wage, right? So each additional hour you earn, the government directly take $2.5 from you because you start at a very high point of $5,000. So what does this look like? CL. This is the original. And the government directly gives you $5,000 when you earn zero. You start from here, but your wage is lower, and so the slope is flatter. And I mean the line is flatter because you have a less negative slope, and the slope will be negative 7.5. This will be your new wage. This wage with a quote. This will be your new wage. And when you earn $20,000, the government will, the amount of the transfer will reduce to zero. So this line and this line will intersect at this point. This is 5,000. Okay. Oh, I'm sorry, I forgot to draw utility curve. For this one, it's quite easy. It looks like this. And for this one, maybe one is here and one is here. You see, this is the most outside point. And for this one, it may be here and here. And it can also be at a corner, maybe at a corner, we don't know. It's just some random utility curves. And Part D guarantees $5,000 per year and reduce that by $5. So if reduced by $5 is quite similar to Part C, but your actual wage will be $5, will reduce to $5. So it's more flat. And we can see if it reduced by $5 every $10, and means when you have an income equals to or more than, what's this amount, equals to or more than $10,000, the money transfer will reduce to zero. So if your income is greater than 10,000 amount, income equals to or greater than 10,000. This is the same as your working hours equals to or the same as 1,000, which means you consume less than 1,000 hours of leisure, and then you cannot benefit from the government transfer, GOV transfer. Sorry for the scratching handwriting, but I think scratchy handwriting, but I think you can understand. Okay, so what does the graph looks like? This will be the leisure, this will be the consumption. First, it's the same. You got $5,000 right away. And then it's flatter than the previous one. And this point should be 1,000 hours, because if you work less than 1,000 hours, if you work more than 1,000 hours, which means you consume less than 1,000 hours of leisure, you cannot benefit from the program. And then your budget constraint will be the same. So for the utility curve, it may look like this, as here. Make sure those are, what's a word? Those are, I forget. Yeah, those are the tangent points. Make sure these 2 points are the tangent points. So that's part D. Part E, if we further assume that there's no income effect, and only substitution effect. So just a review, income effect is caused by your increase in income in the total amount of income, and the substitution effect is caused by the relative change of the price. So we can see income effect is parallel shift of budget constraint, while the substitution effect means means a shift or change in slope. So it's a twist, like a twist, and this will be a parallel shift. If we assume no income effect, which plan, I mean A, B, C, D, which plan will be totally a waste of time? Definitely it's A, because A only have parallel shift. We can see the graph here. A only have parallel shift from this black one to the red one. So A will make no sense. Cannot, or maybe cannot improve or increase utility level. So let's go to the 1, 2, 3 for part E. Part 1, the largest, which anti-poverty program will have the largest reduction in hours worked for someone who would have worked 250 hours under no transfer? If maybe not you, sorry. If a guy works 250 hours with no transfer, his income will be 2,500. So he will be at this part. In this graph, maybe this part, the blue part. In this graph, this part. In this graph, this part. In this graph, this part. So make comparisons. For a person here, how can you maybe increase his utility? How can you improve his utility? By changing the budget constraint. And be aware, you can only make non-parallel shifts. If it's a parallel shift like A and like A, that makes no sense. So for non-parallel shift, we can see the non-parallel shift is the, let me write it down here. Oh, what's happening? Yeah, the non-parallel shift is greater, maybe is significantly greater in plan B. So this tells us plan B will have the largest reduction in hours worked. From the graph, how can we express from the graph? From the graph, we can see if previously the guy chose this point, now he will choose this point. Yeah, It means, which means if a guy who previously worked 250 hours in plan B, he will choose not to work at all, right? Only in plan B he can choose not to work at all to get all the $5,000 and improve and have a higher utility. So plan B will, the result for plan B will be 0 hours of working. So this is definitely the largest reduction in working hours. And the second one, the largest reduction. The world's largest Alexa, Alexa. Pedro Avenue in San Antonio is not available. Alexa, stop. And the largest reduction in hours work for someone who would have worked 1,500 hours under no transfer. So it's a person here, over here. 1,500 hours means leisure is smaller than means leisure is $500. It's 500 hours. So this person is over here. I use the right, maybe the yellow one. You can see the yellow point here. The person is at this point. So we can see this is D. Plan D will give no change to this person with 500 hours leisure and 1,500 hours of working time. And plan C will give him a change. And plan B will not give him a change over here. And plan A, we don't consider plan A. So the answer for question number 2 will be plan C. Plan C will give this guy a largest reduction in hours of working. And number 3, the smallest reduction in hours worked for anyone. So if the smallest reduction in hours worked for anyone will be plan A, because plan A will make no difference if we assume there's no income effect. If we assume there's some income effect, means plan A can also maybe have some influence on this. And just a review of the income effect and substitution effect. If we go from here to here, oh no, maybe I should do a non-parallel shift first. If we go from this budget constraint to this budget constraint, so this is the original point we choose, and this is a new bundle. So remember, the way to find the income effect and substitution effect is to find the decomposition point first. It's by drawing a new budget. It's by drawing a budget constraint which is parallel to the new one but tangent to the original utility level. So this is parallel to the red line, but it will be tangent at the blue point with the original utility level. So it's from A to B and to C. From A to B will be the substitution effect, and from B to C will be the income effect. Since B is a point with the same slope as the new budget constraint, and if you want to move from B to C, it's only the income effect, and A to B will be the substitution effect. And the effect is measured or defined by the distance on the x-axis. So this. So if we are saying there's no income effect, means C is like the vertically C and B have the same x value. So C is just above B, like maybe here means no income effect if they have the same value. And from A to B, we only have substitution effect. So that's just a review. And for this question, I don't think you need to draw the decomposition point and analyze like this. You just try to be clear that with no income effect, the smallest reduction happened in A, as A will make no change in the working hours, since A only have income effect, and income effect is assumed as 0, is assumed to be 0. So that's part B, question 1. And part B, question 2. The economy consists of 5 people and the total national income is 3,000. Individuals' respective income levels are indicated in the second column. Actually, the table gives you everything you need to draw the graph, to do the calculation. And the poverty rate, I think the poverty rate here means the poverty line. Since at the World Bank, we use the term poverty line. If the poverty line is $600 per year, means if you are consuming less than, it's an income, right? If your income, you can use income or you can use consumption to as a poverty measure. And here we use income. So if your income is smaller than $600 per year, then you are defined as poor. And if it is greater than $600, then it's not poor. So A, plot the Lorenz curve. So the Lorenz curve develops from the poorest percentage of the population. And here, because we only have 5 guys, so we don't have to use a percentage of the population. We can rank them from the number from 1 to 5, and we can use 1, 2, 3, 4, 5 instead of the percentages. And if we rank them, yeah, actually the table ranks them by their income, so it's perfect. And then we just find their share, like their share of the I think it's not only the share, but their cumulative share. How to spell? Cumulative share of income. Means when we are doing the second person, we are adding his income and the first person's income together. So the first person will definitely be 0.1, and the second person will be 0.25, and the third person will be 0.45, and the fourth person will be 0.70, and the fifth person will be 100. And so the curve looks like this. Yeah. And while you directly, if you link this point 100% and the last point and the origin, if you link them together, this curve will be on the right side of the linked line. So I mean the right line will be on the right side, which means there is some equality problem. So in this nation, in this economy. And question B, what's the poverty rate or incidence of poverty? The poverty rate equals to the number of people people, sorry, over total population. So for this one, it will be 2/5. And this is a formula, and we can also view it as a weighted average of the poverty indicator. So what does this mean? If we generate a new variable, so this is a ID 1, 2, 3, 4, 5, and we generate a variable as a poverty indicator. It's a binary variable, and we will value it 1 if the guy is in poverty, and value it 0 if it is not. So the first person will be in poverty, so it's 1, and this will be 1, and there will be 0, 0, 0. And this poverty rate can be seen as a weighted average, and the weight here is all equals to 20%, right? Like the frequency weight of the individuals. The weighted average of the poverty indicator will be calculated as sigma WI times the indicator I. So equals to 1/5 times 1 plus 1/5 times 1 plus 0 times 1/5, and 0 times 1 over 5, and 0 plus 1, 0 times 1 over 5. So will still be 2 over 5. This can be a little bit complicated, but for the household survey we are doing and for the way of calculating the poverty rate, we are actually using this formula. Since different households or different individuals will have different weights during a sampling process. So that's question B. And question C, what's the depth of poverty? The poverty gap index, that's the weighted average of the second column. So the weighted average of the second column is 1 over 5 times 0.5 plus 1 over 5 times 0.25. And the final result will be 0.15. And question D is actually interesting. It asks you for what income levels of the poor, only for the poor people, how poor can they be, will make the two numbers equal. Will make the poverty rate equals to the poverty index, poverty gap index. So the poverty gap index is the weighted average. Yeah, maybe write it. Weighted average of the depth of the second column, while the poverty rate equals to the weighted average of the poverty indicator I just introduced you. Indicator. So if we want to make them equal, we just need to make the second column equals to the poverty indicator. Oh, sorry. We just need to make those two things equal. Means poverty indicator equals to depth. So poverty indicator is a binary variable. For the poor, it is 0, right? And the depth is calculated by the income subtract the poverty line over the income. Yeah. So when will this be the? Let me see. Oh, I'm sorry, I made a mistake. For the poor people, the poverty indicator is 1. The value for that variable should be 1. And if we use 1 equals to this, we find that yi should be 0. So z over z equals to 1. So if yi is 0, means the income for the poor should be 0. So that's our conclusion, or that's our result. Everyone, everyone in the poor, in the poverty, or maybe in the poverty, should earn $0 of income to make poverty rate equals to poverty gap index. That's a conclusion. And question E, what are the relative benefits between using the two measures? So that's quite practical. In the World Bank, we use the poverty rate quite often, but you can see maybe the poverty gap index is a better measure, since it not only shows you about shows you the information about the poverty, like how many people are in poor, but also the depth of the poverty, like how like about maybe some information about the inequality and the depth of the poverty. So this is a good part for the poverty gap index, but this one is more widely used. And the reason, I think, maybe only two reasons. First, it's really easy. And second, is quite straightforward. By the poverty rate, we can directly tell you, maybe in China, the poverty rate is 0.4%, means in China, there are 0.4% of the people, total population, are in poor. Like 4 out of 100 are in poor. 4 out of 100, no, sorry, 4 out of 1,000 are in poor. So every 1,000 person, there's four people in poverty, living in poverty. So it's easy and straightforward. So that's a comparison between those two measures, two estimates. Okay, so so this is a problem set 3, and I hope you can make use of this video to get something you need. And thank you. Bye.